Hello students, welcome back to the third part on algebraic expression and formula. This particular assignment, we will focus on factorization. So there are a couple of techniques that we have learned for factorization. The first one is known as extracting common factor. So let's look at the first example. We have 16xy plus 20xz. So when we observe, right, each of the term, we'll find that both of them has 4x as the common factor, right? So what I do, I can extract 4x, and when I extract 4x, what remains, right? What remains is 4y, right? Because 16xy divided by 4x gives us 4y. Now 20xz divided by 4x will give us 5z. And there we go. We have successfully factorized it. Okay, another example. This time round, we have negative 12p minus 27q. So once again, negative 3 is the common factor. And no letters is common, so this is fine. So what we have left will be 4p plus 9q. Right? Next example. This time round, we have these three terms. Okay, so let's see. We have 6 common. Yes, 6 is common. Well, we have negative 6h. If we don't want the negative inside the parentheses, we can always extract 6x. Sorry, negative 6, which is fine. And h is common as well, so we can take it out. So what do we have left? We have 1, right? Over here, and then minus 5k plus 4n. Okay, so that's what we have. Alternatively, right, or you can actually take out 6h, and what we have in the bracket over here will be negative 1 plus 5k minus 4n. They are both ways of expressing it is acceptable. Okay, right, moving on. Factorize each of the following again. This time round, there are a couple of terms here. So the second technique that we actually learn when it comes to factorizing is factorize by grouping. Okay, so I can actually group them into two different groups. So I have a yellow group over here, and I have a green group over here. Okay, so if I actually factorize each group separately, so for the first one, I can actually extract 3y. After I extract 3y, I will have b plus 4a. On the other side, I can extract out x, and I'll get 4a plus b. Well, what you need to be able to recognize is that b plus 4a and 4a plus b, they represent the same value, right? This and this, they are representing the same value. So they are common factors. So if I extract them out, right, I have 4a plus b, then I'm left with 3y plus x. So this is fine. Of course, some other ways you can write this is that you can write x plus 3y instead of 3y plus x. They are fine, right? They have the same value. Of course, by convention, we will like the smaller letter first. So if you write it in this way, okay, you write it in this way, it just shows that you follow tradition, right? So it's good. Okay, right, moving on, next one. Okay, so here, same idea. I'm going to extract 2x. And what I'll have left will be 3y minus 2. And then I can extract z, right? If I extract z, I'll get 3y minus 2. So 3y minus 2 is now the common factor. So I extract that again. And I'm left with 2x plus z. There we go. A very straightforward example. Okay, the next example. What do we extract? We can extract 8m, right? So let's extract 8m from the first group. We have 3x plus y. And then over here, because I see negative and negative, right? So minus 6nx and minus 2ny. So it makes sense to actually extract out the negative version. So I'll extract out negative 2 instead of 2, right? It makes things a lot cleaner. And then n is common, so I extract out n as well. Okay, so that will give us what's remaining. 3 x plus y. Okay, so 3x plus y is common. So let's take that out. 3x plus y. And I'm left with 8m minus 2n. But here we have a very interesting situation, right? Because what happened is that you will realize that this portion here, they have something in common, right? 2 is common. So what should we do about this situation? Do we take out the 2? Or should we extract out the 2? Well, of course we should extract out the 2, right? So you can extract out the 2 from here, okay, and end up with a situation where we have 4m minus n, and then you have a 2 here. But it's very messy, right? So my recommendation, actually, using this as an example, right, is that before we start extracting common factor from each group, let's figure out whether there is a way to extract common factor from every term. Which means from this very beginning, it is a good habit, but not compulsory, that if we look through it and we see that, hey, 2 is a common factor throughout the whole thing, and 2 is a common factor throughout the whole thing, why not extract 2 out straight away, right? It will make things a lot neater. And you check it out, that's how it works, right? So we have 3 nx minus ny. So from here, now we repeat the process. It doesn't take a lot. Again, over here we can just extract out 4m, and we will have 3x plus y. And over here, same idea. This time round, we will extract out negative n. Again, we have 3x plus y, right? So from here, 3x plus y is common. This is fine, right? And then we have 4m minus n. So it makes things a lot neater in this case, right? So here, something for you to take note, all right? So next example, what's happening in the next example? Next example, what happens when I look at the first two terms, kx and hy, I realize that they have nothing in common. So when they have nothing in common, it suddenly stumps many students, okay? Don't panic, okay? What we can do is we can always rearrange them so that they have something in common. So I look at kx, maybe I just subtract hx first, right? Before I add the hy. Nothing wrong with this. This makes perfect sense. And when I do this, now suddenly x is common, right? So we have k minus h over here. Similarly, on this side, we have y that is common. So again, h minus k. Now here becomes another interesting scenario, right? We have this situation and we have this situation. Now what's the difference is when we have k minus h and h minus k, they are actually different in sign. So what happened is a minus b is actually the negative of b minus a, which means in this particular scenario, okay, what we can do is instead of extracting y, I extract negative y. When I extract negative y, this is actually k minus h. Now they match, right? Now they match. So from here, we can simplify this to k minus h x minus y. There we go. Okay? So let's take a look at the next one. Next one, they want us to factorize the following. This time round, this is quadratic. Okay? So what we do, okay, we can look at this and say, okay, sure. Let's use our window to help. There are more than one way to express this. This is the way that I like it. But of course, if you were to search for additional help online, you will find that there's a lot of variety of ways to present this. So I put my b square over here. I have my 15 here. And what happened is 15, if I were to break it up, I can break it up either as 1 times 15 or 3 times 5. 3 times 5 give me 8 quite easily. So I'm going to put 5 here. I'm going to put 3 here, right? So that will give me 5b over here. That will give me 3b over here. It looks fine, right? So this is positive, 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 positive. Everything is positive. It's nice, right? So that means that I will get b plus 5 and b plus 3 over here. Okay? So next example, using the same idea, right? Let's just demonstrate one more time. Well, with enough practice, eventually, right, we don't really need to draw this window anymore, right? We can actually work it out mentally in our mind. But as a beginner, it's good to start out by doing this. Okay, it's positive 20. Now 20 can be 1 times 20, 2 times 10, 4 times 5. And yes, 4 and 5 give us 9 quite nicely. So I will expect this to be 5 and 4. Okay, so well, it's positive 20, but we have negative 9c, right? So actually what I want here is negative 5c and negative 4c, so that when we add them up we get negative 9c, which is what we want in the original expression. So this is c minus 4. So now we have that. Let's write it down. This will be equals to c minus 5 times c minus 4. Okay, so this is the also sometimes called the cross method, because there's an alternative way of showing this and it looks like a cross. Okay, well, next one. Okay, so after so just to show you the cross method as well, because that is the way that some of you may prefer, is that we can also work on the same idea, right? Instead of writing them in a window form, we write our m square here, we write our negative 16 here, and we write our positive 6m over here. So m times m give us the m square, right? As for the 16, we can break it as 1 times 16 or 2 times 8 or 4 times 4. Well, 2 and 8 give us a 6 quite nicely. So I'm going to put 8 here, 6 here, right? Sorry, 2. Okay, so we have 8m, we have 2m. Since we want 6m, we want positive here, negative here, positive here, negative here, right? So that's what we can do. This will be m plus 8 times m minus 2. Okay, so you can use either the window or the cross. It doesn't matter. In fact, with enough practice, right, when I look at this, I will start thinking, well, I have negative 12 there. 12, the combos that I can use is 1 and 12, 2 and 6, 3 and 4. Which one will give me a 4? Because I want a 4k. Well, 2 and 6 give me a 4k. So I want positive 2 and negative 6 in order to get negative 4. So from here, very quickly, you can actually do this mental calculation. But this is, of course, for the more advanced students who have a lot of experience. If you are a beginner, don't try this at home. Okay, work it out good old-fashioned way, right? Okay, factorize the following completely. This time round, we have another of the algebraic identity where we can apply. So this is actually x squared minus 12 squared, right? Which will give us x plus 12, x minus 12. How does this work? I'm sure I will explain this to you in person in class, right? But you should be comfortable doing this type of question. Okay, so similarly, this will be 6 squared minus 5y squared, which will give us 6 plus 5y and 6 minus 5y. More examples of this type of question. Well, this is 1 squared minus x squared, which will give us 1 plus x, 1 minus x. One more example. This is actually y squared minus half squared, which will give us y plus half, y minus half. There we go. Right? Okay, next. Well, the next set of questions, this time round, we can actually apply using the algebraic identity as well. Okay, in this case, this will be 2x squared plus 2, 2x, 1 plus 1 squared. So this will give us 2x plus 1 squared. You can, of course, use the cross method on this. It will work, right? You can try it out yourself, right? So over here, what do we have? What we can do here in this case, we can also apply the special identity. We have a plus 3 squared minus 3 squared, which gives us a plus 3 times a plus 3 minus 3, which will result in a plus 6 times a. And of course, you can rewrite it in this way so that it looks neater. It's perfectly fine. Okay, that's what we get. How about this one, right? So this one, again, this is actually x squared minus 2x let's clean it up, 4 plus 4 squared. So it will be x minus 4 squared. Okay, and this one, same, is going to be 5x, right, squared minus 2, 5x, 1 plus 1 squared, which gives us 5x minus 1 squared. Okay, so with this, I hope you practice a little bit more, get comfortable with the idea of factorization, and be a master of this particular skill set, right? All the best.